For question 1, I'll use the following formula that gives me the midpoint. That's x1 plus x2 over 2 for the x coordinate, y1 plus y2 over 2 for the y coordinate. So I have 5 plus 13 over 2, and then I've got minus 4 plus 1 over 2, and this will give me 9 for the x and minus 3 over 2 for the y. For part B, recognize that the gradient is the coefficient of x, so in my case, gradient is minus 3. And then for the last part, it says Lionel has equation y equals 2 minus 3x. Does the point with coordinates 100 minus 302 lie on the line? I'll use the x at x equals to 100. Y comes out to be 2 minus 3 times 100, which is equal to minus 298, which is not equal to minus 302. So as a conclusion, it does not lie on line L. For question 2, I'll start by writing these numbers as product of prime numbers. So for 28, I'll divide by 2, quotient 14, again by 2, I have a 7, and then 7, 1. So 22 equals 2 squared times 7 to the power of 1. And then for 105, let's divide by 3. I'll get 35, divide this by 5, gives me 7, divide by 7 gives me 1. So 105 is equal to 3 to the 1 times 5 to the 1 times 7 to the power of 1. Now the lowest common multiple is equal to all of these numbers to the highest power. Now 2 has a power of 2, everything else has a power of 1, which means that the lowest common multiple is 420. For question 3, I'll split this shape into 2 rectangles. Now the red one has dimensions 12 times 9, which gives me 108 for the area. Now for the blue one, note that this height is equal to 3. It's equal to 9, which is this one, minus 6. So I've got a 3. So the area is equal to 3x. So if I add these two numbers, 108 plus 3x, I should get 129. So 3x is equal to 21, x is equal to 7. For question 4, part A, the modal class is the class with the highest frequency, and that's the class between 3 and 4 because the frequency is 16, which is the highest. For part B, to find an estimate for the mean, I will need to use the formula sigma fx over sigma f. Now the sum of the frequencies is equal to 40. This is given in the question. Now fx is the product of the column labeled frequency times the weight, but since I have an interval, I'll need to pick a number in this interval, and the best number to choose is the midpoint. So I'll need an extra column for the midpoints and an extra column for the product of the midpoints and the frequency. Now the midpoints are 2.5, 3.5, 4.5, 5.5 and 6.5, and if I do the multiplications of midpoint times frequency, I will get 30, 56, 40.5, 11 and 6.5. Now if I find the sum of this column, it's going to be 144, and this is what I will divide by 40 to get an answer of 3.6 kilograms. For part C, one of the 40 babies is chosen at random. What's the probability it has a weight more than 5 kilograms? Now, from the table, there are 3 babies with a weight more than 5 kilograms. So my answer here will be 3 over 40. For question 5, note that since my ratio is 3 to 5, I have a total of 8 parts. Now, 3 parts are girls, so 3/8 of 120, which is 45, are girls, which means that 5/8 of 120, which is 75, are boys. We are given that 16 over 25 of the boys go climbing, which means that the rest 9 over 25 of the boys go sailing. Hence, 9 over 25 times 75, which is the number of boys, is equal to 27. These are the boys that go sailing. Now, let's have a look at the girls. X girls go climbing, which means that 2x go sailing, because we're being told that twice as many girls go sailing as go climbing. So in total, 3x girls equals 45. So x is equal to 15. So 2x is equal to 30, and these are the girls that go sailing. So the total number that go sailing is equal to 27 for the boys plus 30 for the girls, which is 57. For part A, the answer is 0.00078. Now for part B, although you can put this on the calculator and get the answer, I'll try and do some manual work. Now, the numerator is 5.6 times 10 to the 4, and then I'm going to add, and I'll have to change 7 times 10 to the 3 to 0.7 times 10 to the 4. So these two numbers have the same power of 10. This will be over 2.8 times 10 to the minus 3. So the numerator now becomes 6.3 times 10 to the 4 divided by 2.8 times 10 to the minus 3. Now, if you divide 6.3 by 2.8, you get 2.25 times 10, and then you will need to subtract the powers. 4 minus minus 3 is 7, and this is my final answer. Expanding the expression in part A gives me m squared plus 5m minus 8m minus 40, and this simplifies to m squared minus 3m minus 40. Now for part B, I'm going to take out a common factor of 5y, and I'll be left with 1 plus 4y, and this is the final answer. Regarding part C, anything to the power of 0 is always 1, and that's the answer to this part. And for part D, to solve this equation, I'll start by expanding the left-hand side. So I've got 6x minus 15 equals 9 minus x over 2. Now I'm going to multiply both sides by 2, so 12x minus 30 is equal to 9 minus x. Now I'm going to take the minus 30 to the right and the minus x to the left. So I will have 13x equals to 39, which means that x is equal to 3. In question 8, I'm given this trapezium and I need to enlarge it by a scale factor of 1/2 and center 1, 2. Now what I'll do at the beginning is join each of these corners to the center, which is 1, 2. The next step that I will do is to find the midpoints of those lines. The reason I'm going to find the midpoints is that the scale factor is 1 over 2, so I need to cover half the distance from the center. Now the midpoints are the following: 6, 3, 8, 3, 8, 6, and 4, 6. And then I will join those midpoints, and that will be my image. In question 9, I know the adjacent side to 63. I need to find the hypotenuse. So I'm going to use the cosine. Cos of 63 equals to the adjacent over the hypotenuse. Let's cross multiply to get PQ equals to 24.3 over cos of 63. If I put this on the calculator, it will give me 53.5, which is the final answer. For question 10, I've got 3 lines that bound a region. I'll first find the equation of the lines and then the inequalities. Now I'm given one of the lines. The vertical line here has equation x equals to -1. So I will need to find the equation of the line that passes through 0, 4, and 4, 0. Now if it passes through 4, 0, and 0, 4, it means it has a gradient of 4 minus 0, 0 minus 4, which is -1. I know that the y-intercept is 4, so the equation is the following: y equals minus x plus 4. Now, the shaded region is above this line, so my inequality will be y bigger than or equal to 1/3 of x minus 2. It is to the right of this equation, so I'm going to have x is bigger than or equal to -1. And finally, the shaded region is below this line, so the corresponding inequality is y less than or equal to minus x plus 4. For question 11, an interest rate of 1.5% corresponds to a multiplying factor of 101.5 over 100, which is 1.015. So I start with 6,000 times 1.015 squared, because that's for 2 years, times another multiplying factor, and this will give me 6,311.16. So the multiplying factor for the last year is 6,311.16 over 6,000 times 1.015 squared. Now this gives me 1.021, which can be thought as 102.1 over 100, and that's 2.1 above 100, and that's the interest rate. In question 12, I've got a cumulative frequency graph for 80 men and women that took part in a race. And in part A, I need to find an estimate of the interquartile range. I'll start by calculating Q1, which is a quarter of 80, and that's 20, and I need the 20th observation from the graph. I'll also need 3/4 of 80, which is 60. That's the 60th observation from the graph. To find these numbers, I'll find 20 and 60 on the vertical axis and then read off their corresponding x coordinates. So the values I get are 38 and 56. So the interquartile range is their difference, which comes out to be 18 minutes. Now for part B, we're given that 60% of the men took less than 50, but no women took less than 50. So what I'm going to do is go to the graph and find the total number of people that took 50 minutes or less. The answer I get is 42. This means that 42 people took 50 minutes or less. We are given that 0 women took 50 minutes or less. And if I subtract, I will find that 42 men took 50 minutes or less. Now, 42 is equivalent to 60% of the men. How many men corresponds to 100%? And if I cross multiply, I'll do 42 times 100 over 60. I will get an answer of 70. For question 13, I'll start by using the given formula. Pressure is equal to 0.14. This is equal to the force, which is 56, over the area. So if I rearrange this one, area is equal to 56 over 0.14, which will give me 400 centimeters squared. Now the area of the face that is in contact with the table is the following. This is a square of side W, so W square is equal to 400, which means that W is equal to 20 centimeters. So the volume is given by 20 to the power of 3, which is 8,000 centimeters cubed. In question 14, part A, to find the area of the parallelogram, I will consider the triangle FEG. That's half of the parallelogram. Once I find this one, I will multiply by 2 and find the area. The formula I will use is the following. Since I'm going to use angle 106, the two sides I'm going to use are the two adjacent ones. So let's plug this into the formula, and we have area equals 1 over 2 times 9.3 times 14.7 times sine of 160, and I'm going to multiply this by 2, and this gives me 131 centimeters squared to 3 significant figures. For part B, I'll use the same triangle, and in order to find EG, I will use the cosine rule. The cosine rule states the following. Again, let's substitute the values in. So I've got EG squared is equal to 9.3 squared plus 14.7 squared minus 2 times 9.3, 14.7 cos of 106. This comes out to be 377.94 and so on. So EG is the square root of this number, which gives me 19.423 significant figures. For part A of this question, the volume is equal to the base times the height times the depth. Let's expand the first two brackets. This is going to give me 2x squared plus 2x plus 5x plus 5. Let's simplify. That's 2x squared plus 7x plus 5 times the other bracket. And now let's expand this. 6x squared plus 21x plus 15 minus 2x cubed minus 7x squared minus 5x. And if I simplify this, I'm going to get 15 plus 16x minus x squared minus 2x cubed as required. For part B, to find the maximum volume, I will need to differentiate. So dv dx is equal to, and let's rewrite this expression so I can have it on the next page. So 15, when you differentiate, it becomes 0. 16x will become 16 minus. For the next one, I'm going to bring the power down. It's going to be 2x, reduce the power by 1, minus, and then repeat again, 2 times 3 is 6, x to the power of 2. And this will be equal to 0. The reason is because I'm looking for a maximum or a minimum. So let's rearrange this one. So I've got a positive x squared coefficient, 6x squared plus 2x minus 16 equals 0. I'll divide this by 2. 3x squared plus x minus 8 is equal to 0. I will not attempt to factorize this one. I'm being told that the answer, the value of x, will be correct to 3 significant figures, so I won't be able to factorize. So I'm going to use the quadratic formula that says the following. Now, a is the coefficient of x squared, which is 3, b is the coefficient of x, which is 1, and c is the constant term, which is minus 8. So let's substitute this in. X equals 2. We've got minus 1 plus or minus the square root of 1 squared minus 4 times 3 times minus 8 over 2 times 3. So I get an x value of minus 1.81, or x equals to 1.47. Now, x cannot be negative because this will be negative. If x is minus 1.81, the height will be negative. So I will reject the first one. So x is 1.47. For question 16, first I'm going to write a is between 58.35 and 58.45. B is between 19.5 and 20.5. And finally, D is between 3.55 and 3.65. Now, I want the maximum value of P, so I need the numerator to be as big as possible in the upper bound of the numerator and the lower bound for the denominator. Now, since I've got a subtraction in the numerator, I'll need the upper bound of the first number minus the lower bound of the second, which means I will use the following number: 58.45, 19.5, and 3.55. Sorry. Let's substitute these values in. So I've got 2 times 58.45 minus 19.5 over 3.55, and this comes out to be 27.44. For part A, I will use the following identity. Let's start with the left-hand side. I've got 6 plus 2 root 12 squared. This is equal to 36 plus 2 times 6 times 2 root 12 plus 2 root 12 squared. Now note that 2 root 12 squared. It's like saying 2 root 12 times 2 root 12. This is equal to 4 times 12, which is 48. So I've got 36 plus 24 root 12 plus 48. Now 36 and 48 is equal to 84 plus 24, and now I'm going to write square root of 12 as square root of 4 times square root of 3, which is 2 root 3. 24 times 2 is equal to 48 times root 3. And if I take a common factor of 12, I'm going to get 7 plus 4 root 3, which is equal to the right hand side as required. For part B, I'll start by flipping the fraction, so t to the power of 15 over 27, a to the power of 12, and this is to the power of a positive 2 over 3. Now this power applies to every term, so I've got t to the power of 15 to the power of 2 over 3 over 27 to the power of 2 over 3 times a to the 12 to the power of 2 over 3, and this will give me t to the power of, and I'll have to multiply these powers, so I get t to the power of 10. Now note for 27 to the power of 2 over 3, this is equal to the cube root of 27 squared. The cube root of 27 is 3, and you square it to get a 9. So I've got a 9, and then again for the a's, multiply the powers, you get a to the power of 8, which is my final answer. For question 18, I've got 3 types of sweets, total of 16 sweets. 3 people are choosing at random, and I want the probability that after the 3 people choose one, the 5 lemon sweets are still in the bowl. Now let's think in terms of a tree diagram. I'm going to draw the tree diagram. You don't have to draw it, you can think about it. So this is how the tree diagram looks like. L stands for choosing a lemon sweet. L dash not a lemon sweet. Note that we are not interested of the flavor. I'm only interested whether it's a lemon or not. Now what we want is that there are 5 lemon sweets still in the bowl, which means I want 3 picks that are not lemon sweets. So I'm interested in the following. Now the probability of originally choosing a lemon is 5 over 16, which means 11 over 16 is the probability of not choosing a lemon. Now after one is gone, there are 15 of them, and 10 are not lemon. So 10 out of 15 is the probability of not choosing a lemon in the second pick, and then there are 9 non-lemons out of 14. And to find this probability, I will multiply the 3 probabilities. So I have 11 over 16 times 10 over 15 times 9 over 14, and this will give me 33 over 112. For question 19, I'll start by considering the triangle FEH, and the purpose is to find FH. Note this triangle is a right angle triangle. Let's extract and redraw. So using Pythagoras, FH squared is equal to 5 squared plus 9 squared, which is 106. So FH is the square root of 106. Now to find the required angle, consider the following triangle. Again, this is a right angle triangle. The base FH, we just found it. The height AF is 6 and we need angle H. Let's redraw this triangle. So tan of angle H equals opposite over the adjacent. So H is the inverse of tan of this number. So H is equal to 30.2 degrees. For question 20, first have a look at the coefficient of the bracket. That's the coefficient of x squared once expanded, and because this is a positive value, it means that I have a positive quadratic. To find the coordinates of the minimum point, consider the bracket. The value that makes this bracket equal to 0 is the x coordinate of the turning point, and what remains is the y coordinate of this turning point. In our case, we have a value of x of 1, and if the bracket goes away, I have a y coordinate of minus a. To find the y-intercept, I'll just consider what happens when x equals 0, and this gives me y value of 4 times minus 1 squared minus a, which is 4 times 1 minus a, which is 4 minus a. So the coordinates of this point are 0, 4, minus a. Now note, because a is bigger than 4, 4 minus a comes out to be negative. We will also need to find what happens when y is 0. So let's write this down. When y is equal to 0, we have 0 equals 4x minus 1 squared minus a. Let's take the a to the other side. So a is 4x minus 1 squared. Let's divide by 4. A over 4 is x minus 1 squared. Take the square root, so plus or minus the square root of a over 4 is x minus 1. And let's also take the 1 to the other side. So we've got 1 plus or minus, and if I take the square root of separately the numerator and denominator, I have square root of a over 2. And these are the two x coordinates that cut the x-axis. So I have a minimum somewhere here. I have a y-intercept somewhere there. I have two roots, one here, one here. So let's draw this graph. Let's label the points. I've got a here, b the y-intercept, c is the positive root, and d is the negative root. And let's write the coordinates down. I'll start question 21 by finding h of x. This is f g of x. So I'll substitute function g into function f. So I've got f of x plus 3. This means that I have x plus 3 squared minus 2x plus 3. Let's expand. X squared plus 6x plus 9 minus 2x minus 6. This is equal to x squared plus 4x plus 3. Now, since I'm going to find the inverse, whenever I have a quadratic, I must always complete the square. So this is going to give me x plus half of 4, which is 2 squared minus 2 squared plus 3. So x plus 2 squared minus 4 plus 3, which simplifies to x plus 2 squared minus 1. Now, to find the inverse, I will reverse the roles of x and y. Imagine I have a y here. So I'll start by writing x equals to y plus 2 squared minus 1. I'll take the 1 to the other side, so x plus 1 equals y plus 2 squared. Let's remove the square, so plus or minus the square root of x plus 1 equals y plus 2. So y is equal to minus 2 plus or minus the square root of x plus 1. Now note that for h of x, x is bigger than or equal to minus 2. This is given by the question. So for the inverse of x, it means the y is bigger than or equal to minus 2, since the roles are reversed. And if I want the y value bigger than or equal to minus 2, it means that if I start with minus 2 here, I'm going to need the positive value to get something bigger than minus 2. So my function, the inverse function, will be minus 2 plus the square root of x plus 1. I'll start question 22 by drawing a rough sketch of this scenario. Now this is not the right orientation, but it doesn't really matter at this stage. I will start writing equations for each statement that I am given. I'm given that m is the midpoint of jk. The equation for the midpoint is the following. So in our case, we get j plus 6 over 2, 15 plus k over 2, and this is point m. Now I'm given that the gradient of hm is equal to 2. The formula for the gradient is the following. So in our case, the gradient of hm is equal to 15 plus k over 2 minus 1 over j plus 6 over 2 minus 4, and this is equal to 2. Now note that hm is perpendicular to jk, and we know that for perpendicular lines the following holds. So in our case, the gradient of jk, which is given by k minus 15 over 6 minus j, must be equal to minus 1 over 2. And finally, I will use the fact that jk is square root of 80. The distance between 2 points is given by the following formula. Hence, jk is equal 6 minus j squared plus k minus 15 squared, square root of that, and this must be equal to square root of 80. Now I have 3 equations here. Let's label them 1, 2, and 3. And I will use 2 of them to solve simultaneously so I can find j and k. Now I have chosen to go with 1 and 2, but you can use 3 as well with either 1 or 2. Let's simplify those equations first. So equation 1 simplifies as follows. 15 plus k over 2 minus 1. If I cross multiply this one, I will get 2 times j plus 6 over 2 plus 4. Let's convert these into single fractions. So 15 plus k minus 2 over 2 is equal to 2 times j plus 6 plus 8 over 2. I can cancel out these 2's. So I will have 13 plus k over 2 equals to j plus 14. So 13 plus k is equal to 2j plus 28. So k is equal to 2j plus 15, and this is a simpler version of equation 1. Now let's simplify equation 2 as well. So we get 2, k minus 15 equals minus 6 minus j. This is just cross multiplying. So 2k minus 30 equals to minus 6 plus j, which means that 2k minus 24 is equal to j. And now I will try and solve this simultaneously. So I'll substitute the first one into the second one. 2j plus 15 minus 24 equals j. So 4j plus 30 minus 24 is equal to j, which means that 3j equals to minus 6. J comes out to be minus 2. And then k is equal to, I'll substitute the j I found into this one, 2 minus 2 plus 15. K comes out to be 11, so minus 2 and 11 are the final answers for this question. Note that if you use equation 3, you will have a quadratic equation, so you will get 2 values for j and 2 values for k, and you will have to choose the negative j because it says so in the instruction.